Hi, in this video, we're going to talk about VTP messages. Okay, so VTP messages include a VTP Summary Advertisement. These messages are sent every 5 minutes by default. Okay, what they do is they form the adjacent VTP switch of the current VTP domain name and something known as the configuration revision number, something very important to VTP. The receiving switch compared the VTP domain, make sure it belongs to the same domain, to its own VTP domain. If the name is different, the switch will simply ignore the packet. In this case, is switch B in the same domain as switch A? Yes, it's the same. Okay, so since the name is the same, it's going to compare its configuration revision number to the one sent in the summary advertisement. If its own configuration revision number is higher or equal to the one in the summary advertisement, it will ignore the packet. So is its own configuration revision number higher or equal to the sender? Well, switch B has a configuration revision number of 0. The one in the summary from switch A has a configuration revision number of 2. So no, it's lower. So in this case, a VTP advertisement request is sent by switch B back to switch A, the server. Okay, now you'll notice that they're both servers in this case, which is fine, but typically you'll have the servers be sending to the clients. We'll talk more about that in a moment. Important to note that whenever you add, delete, or change a name of a VLAN on a VTP server, any VTP server, even if there's multiple ones, it increments the configuration revision number, one for each VLAN modified, and a summary advertisement is sent. We'll see this in more detail in a moment. Okay, so we said that after the VTP advertisement request is sent by switch B, a VTP subset advertisement will be sent. Okay. So in this case, we have added 2 new VLANs to switch A, okay, VLANs 2 and 3. Now notice what happens to the configuration revision number. It goes from 0 to 2, okay, incremented by 1 for each VLAN, okay. So this server, switch A, will send a VTP summary advertisement. Okay. The server will also send a VTP subset advertisement. In this case, let me go back here a little bit. Notice that look at switch B. Look at the configuration revision number. It's going to change from 0 to 2. The same configuration revision number sent by switch A, because switch A had a higher configuration revision number. Okay? And it will also update its VLAN list to match that of switch A. So it synchronizes itself with the server that had the higher configuration revision number. Okay. All right, let's take a look here. Right now we have 3 switches. By default, all 3 switches are VTP mode server. Notice that on all 3. Notice that they all have 0 as their configuration revision number. They're all just have their switch, their VLANs are only VLAN 1. It's only VLAN that's been configured at this point. And the VTP domain name is null. So this is the default. Okay, let's say that we have configured switch B to be client and switch C to be in transparent mode. The VLAN server in this case will maintain, which is switch A, maintain a list of all VLANs in NVRAM, non-volatile RAM. So when we reboot, that information is still there. However, the client switches, we do not add, delete, or rename VLANs. It gets all of its VLAN information from the VTP server. So the client doesn't store VLAN information in NVRAM. If the client reboots, it's going to lose all of its VLAN information. It's going to rely on the VTP server to have all that information restored. Okay, so transparent mode switches have their VLANs configured manually. They don't participate in VTP or advertise their VLANs. Okay. It's ideal for switches with VLANs which should be local to that switch. We'll see that in a moment. Okay, we have a VTP server, switch A. The domain name on that we're going to configure as Cisco. So now it's in VTP domain Cisco. Notice that the other switches are still in VTP domain null. Okay. If VLANs 2 and 3 are going to be added onto the VTP server. So let's go ahead and do that. We add those 2 VLANs. Notice the configuration revision number is going to change from 0 to 2, 1 for each VLAN. Okay. Now remember, VTP only works over trunk links, 802.1q trunk links. Okay, so we've got the trunk links configured. Okay. Switch A is going to send a summary advertisement. Let's take a look at its message to switch B. Includes both the domain name and revision number. Switch B is, in this case, is going to update its domain name from null to Cisco. Because the server has a higher revision number, summary in the summary, the advertisement summary, the switch B will reply with an advertisement request. Switch A will respond with a subset advertisement, which will actually be used to update the information on switch B. So switch B updates its configuration number to match the server and its VLAN information. Now, by the way, typically you wouldn't want to do it this way. You'd want to have the switches all configured with a domain name already and a password, okay? So the password is important. Otherwise, if you don't have the correct domain name and password on your client and even your transparent switches, they will not participate in the VTP domain with that server. So we want to have the server, the client, and the transparent switches not only with pre-configured typically with the domain name, but also with a password. Okay, let's get back to these advertisements. So let's see what happens when the VTP advertisements, I'm showing them both together, are sent to a transparent switch. Switch C doesn't make any changes. Why? Because it's a transparent switch. Okay. Let's say we configure switch C, the transparent switch with the domain Cisco. And let's add some VLANs. Okay. Well, even though it's in the same domain, even though we've configured some VLANs, okay, it's not going to advertise that information to any other switches. It's not a server switch, first of all, so it's not going to, in this case, propagate this information. The configuration revision number remains at 0 even when the VLAN configuration information is changed. So, however, transparent switches will relay VTP messages it receives to other switches. Let's take a look at how this works. Okay, so let's take a look. VTP-D has now been added to the network. Okay, we have a trunk link between C and D. Okay, switch A sends the summary advertisement, and notice that's to switch out to switch C, and switch C is going to go ahead and forward that information. Although it won't do anything with it because it's a transparent switch, it will forward that information. Okay, switch D is going to reply with the advertisement request. Switch A sends the subset advertisement. And because Switch D has a lower configuration revision number, belongs to the same domain, and let's assume we're using passwords here, has the correct passwords. It updates the revision number and the VLAN information. Okay, no changes to the revision number or VLAN information on the transparent switch. Now, I mentioned that the server propagates the VLAN information, and that's typically where we're going to add all of our VLAN information is to the VTP server, and it gets propagated to our VTP clients. We will talk about an instance where a VTP client might be added to the network with a higher revision number, and because it has a higher revision number, can actually propagate and change information on a VTP server. That's not a situation we normally want, and we're going to talk about that in a later video. Okay, I hope this helped you understand a little bit more about VTP messages.